Hello, I'm Pat Johnson, Head of Marketing at Moderne. I'm here with my colleague, Kevin Carpenter, who leads engineering, and we're going to take you through how to massively pay down your technical debt. For the next 15 minutes or so, try to set aside your existing paradigms for how you manage code maintenance, migrations, and security, and take in that exponential power of multi-repo, mass-scale refactoring with us. So let's jump right in. The growing impact of technical debt has become the biggest obstacle to making changes to existing code bases. One report cites technical debt as a $1.5 trillion problem in the US, and that by 2025, 40% of IT budgets will be spent simply maintaining this debt. Now, there's the technical debt that developers work at every day. That's what you see on that exposed surface area of the iceberg. And then there's the under the surface debt, under the water, that deferred maintenance and upgrades. It's included things like older frameworks that are reaching end of life and security vulnerabilities that are just waiting to be exposed. These issues often show up on a critical path for your developers as a major migration project that could take months to complete, or an urgent remediation due to a security breach. Technical debt is not only expensive to maintain, it also comes at a significant opportunity cost for your business. It makes code harder to update and evolve, and much harder to build new innovative features. It can also be a top contributor to why software modernization projects fail. Today, we want to talk to you about how to eliminate technical debt at scale. During this short presentation, you'll get to experience the Moderne platform value and capabilities and leave with a good understanding of how you can apply our revolutionary technology to your organization's technical debt needs right away. Moderne is a developer collaboration platform for automated code refactoring and analysis, enabling your teams to migrate, maintain, and secure source code with speed and accuracy at mass scale. With Moderne, those months-long framework migrations are a thing of the past. Instead, you can track the progress of software migrations and automatically upgrade lagging projects. This can be a major framework upgrade, like for the latest Spring Boot version, or a migration from one technology to another, or even a migration to cloud-native technologies. And instead of urgent security fixes that can consume your development teams for weeks on end, you can continuously keep an eye on your most critical security vulnerabilities, like the OWASP Top 10. Then you can readily identify your high-risk areas and fix your code immediately. And you can keep your code clean and compliant all the time, as well as stay on top of those breaking changes. With Moderne, you get comprehensive, accurate visibility into your code base, enabling your teams to analyze issues, understand impact and effort, and stay aligned. In a real-world setting, this shows up as a significant boost in developer productivity. Take, for example, this mid-sized insurance company that was averaging one large maintenance project per quarter. Each project would consume the entire development team's effort and halt feature work for a good chunk of that time. You can see in the graph that their Q2 involved a particularly onerous migration that took more time, which also resulted in fewer business stories getting closed that quarter. Using the Moderne platform, you can see the results were quite different in Q4, when the development organization showed an 1,100% increase in closed maintenance stories. Their business partners were a bit worried at first that the developers were not focusing on those new features, but then the development team was able to show that they completed 30% more business stories as well, with all the time that they had saved. Now I'm going to hand it over to Kevin to introduce you to the Moderne platform, and he's going to walk you through those key tech debt use cases and demonstrate the power of mass scale auto refactoring.
Thanks, Pat. So what does mass-scale automated code refactoring look like in practice? The Moderne platform enables you to see your code base across hundreds to thousands of repositories and make accurate automated changes to the relevant files in those repositories. In this example, Moderne was focused on finding static analysis issues in 139 repositories. We were able to automatically fix issues in 13,500 files in just over 4 minutes. A developer can then check the diff and do a mass commit. If this were developers spending 3 to 5 minutes per issue, this would take around 75 days to make the complete code changes. At Moderne, we want to help your teams tackle these hard technical debt problems and drive substantive change across organizations. That's why we're excited to announce the Moderne Dev Center dashboard as part of our platform. This is a place where developers can collaborate and make code better all the time. Here at the top, you can see statistics about your organization. We see the total number of repositories, the number of unique developers that have committed to these repositories in the last 90 days, and the total number of lines of code. Below that, we have the framework upgrades and migrations section. This section shows the current status of any such migration goals, such as a framework upgrade, getting on the latest Spring Boot or JUnit, a language version upgrade, such as getting on the latest Java, and even a migration from one framework to another, such as migrating from Struts to Spring. One upgrade or migration can take thousands of steps. For instance, the full migration to Spring Boot 3.2 encompasses over 1,700 steps. This includes things as simple as updating properties to new formats or updating dependencies to new versions, to more complicated steps that require in-depth code changes. Next, we have the visualization section. Today's code bases are complex, and now with generative AI in the game, more code can be written more quickly. Leaders and teams find it difficult to get insight into the state of their code, and doing so requires expert research, generally from senior engineers, to resolve. Just the process of understanding your code base can take many hours, and the data can often be outdated by the time you try to put it to use. What if you could visualize your code base in minutes? Visualizations, a feature of the Moderne platform, allow you to see at a glance what might take hours of research and scripting to accomplish. And finally, security. The expectations on development teams just keep going up. Where you used to have a single team dedicated to a single application, now one development team may manage several applications. Even though the expectation on that team is heavily skewed toward feature development, that team is responsible for making sure their applications are secure as well. The security section of the Moderne Dev Center shows you a breakdown of the most important security priorities for your organization. Let's take a look at an example Dev Center. The view on the Moderne Dev Center is of a specific organization. We use the word organization to mean a team, department, company, really any group that wants to see the status of and collaborate on improvement of their code base. You can also think of an organization as a set of source control repositories that any group of developers collaborates on or any leader wants to track. Today we'll be showcasing the Moderne Dev Center for the OpenRewrite codebase. OpenRewrite is the open source auto refactoring technology sponsored by Moderne that runs at scale within our platform. You can see our framework and migration goals include the Spring Boot 3.2 upgrade, which is complete, the JUnit 5 upgrade, which is complete, and the Java 21 upgrade. And it looks like we've got a ways to go to get to Java 21. 86% of our repositories are still on Java 8. Let's see what it takes to get to Java 21. So our Java 21 upgrade not only makes the minimum set of changes required to get you onto Java 21, but also changes to take advantage of new features in the new language version. So let's take a look at one of these repositories. So you can see here that we're taking advantage of a new Java 21 feature, replacing get with an index of the first or the last of the collection with get with .get first. Similarly, because in order to be on Java 21, you first have to be on Java 17, our Java 21 upgrade also includes the entire Java 17 upgrade. And going even further, our Java 17 upgrade includes the Java 11 upgrade and so on and so forth. So you could be on Java 8 and immediately upgrade directly to Java 21 without any steps in between. Another such example, because we upgrade to Java 17, you can see here we're taking advantage of a Java 17 feature, statement instance of j.return, return 1. This is instance of pattern matching. And so rather than have to cast this to call methods on a j.return, we just directly get a j.return here and call return1.getExpression. And because there are so many steps as part of this upgrade migration, if you want to see which specific steps made a change, click these three dots, click why did this change? And now you can see here, changes code to use Java 17's instance of pattern matching, and replace list.get add and remove with sequence collection first and last methods. And then you can come here to the results view, click this checkbox, and directly commit all these 36 results. Generally, we submit pull requests for these. So this would commit to 36 different repos using the credentials of the user who's logged in. And so these pull requests would be in your name. Let's take a look at the visualization section in the Dev Center now. Let's visualize our usage of Jackson modules across the OpenRewrite organization. Jackson is the most popular serialization library for Java used by Spring and other open source frameworks. A mismatch in Jackson versions across your codebase can lead to serialization errors, and outdated versions of Jackson can lead to security vulnerabilities. So this is a violin chart that shows the usage of each of these modules, and the width of the violin chart is the number of times that dependency is pulled in. So zooming in just on Jackson Core here, we can see that Jackson Core version 2.16.1 is pulled in 209 times across the OpenRewrite codebase. 2.16.2 specifically for this module is not pulled in at all, and 2.17.0 is pulled in 5 times. So this is useful for seeing if we need to upgrade everything to 2.17.0 or if we're completely missing the latest version. Let's look at another visualization. We have one enterprise customer who's a heavy user of Gradle and has had trouble getting all of their teams on the latest version of Gradle. Updating Gradle and the Gradle wrapper allows teams to take advantage of both security updates and performance improvements in Gradle. As part of this initiative to get every team on the latest, they did an impact analysis to see how far behind each team was. Let's take a look at Gradle wrapper usage across the OpenRewrite organization. So you can see here the vast majority of our repositories are on the 8.7 latest Gradle wrapper. There's a couple still on 8.6, and we've just got one hanging around on 8.4. It's worth noting we also have a migration to immediately put you on the latest Gradle wrapper. And now let's look at security. So on the OpenRewrite organization, our priorities are making sure we follow the OWASP top 10 standard and a few other security related recipes. So let's take a look at OWASP A01 broken access control. This looks at and fixes issues such as not meeting principle of least privilege. So let's take a look here at rewrite. And similar to upgrades and migrations, these security recipes can also have multiple steps. And so if you want to see which specific one is making changes here, same steps. 3 dots, why did this change? And you can see we're fixing a partial path traversal vulnerability. And finally, one of the most important aspects of security is keeping your dependencies up to date. OWASP A06 is designed to keep all of your dependencies up to date to get you on the first non-vulnerable version of a dependency, but you can see that the OpenRewrite organization is already up to date. So let's run this on another organization and show off this feature. So find and fix vulnerable dependencies. We're going to choose runtime scope, which is the widest scope. We're more likely to find results. We're going to override transitives because we've discovered through our analysis on code bases that we've done that 80% of vulnerabilities are in transitive dependencies. Meaning you pull in a dependency that's not vulnerable and it pulls in a dependency that is vulnerable. And you want to override that version in your code. So we're going to override transitives and then we're going to run this. So let's take a look at some of these results. So you can see here we've updated the version of Logback Classic to 1.4.12, and you can also see we've added this to a dependency management section because this is not a direct dependency of this repository. This is being pulled in transitively. This works with both Maven and Gradle. Let's take a look at a Gradle example. So for Gradle, we can also add a because, and you can see we've added the specific CVE that makes HTTP client vulnerable. And so similar to before, we can click all of these, commit, and we'll commit to these 9 repositories. So how does all of this work? There are 3 major components at work here that allow us to make these large-scale upgrades and security fixes. First, we have the lossless semantic tree, which you can think of as analogous to an abstract syntax tree, but with a lot more information. For instance, the lossless semantic tree contains all types in use across your application and all of its dependencies, as well as the full details of whitespace to make sure any changes made through this process are accurate and preserve your particular style. The first step in the process is to parse your code and turn it into this LST format. Then we run OpenRewrite recipes and other auto refactoring technologies, such as JavaScript code mods, on this LST representation of your code to do impact analysis and make automated changes. OpenRewrite recipes are deterministic programs. You will be able to trust that these recipes will make accurate changes every time in every location. Do you remember earlier when I told you the Spring Boot 3.2 recipe had 1,700 steps? This here is a visualization of that entire migration. You can almost see all 1,700 steps represented here. And finally, in order to be able to run on your entire codebase at once, we distribute the work of running these refactoring technologies to worker nodes within our platform. Because some repositories are monorepos or otherwise have a very heavy LST, the entire LST is not guaranteed to fit in memory. To solve this, we deserialize fragments of the LST from disk, run the refactoring technology on each fragment, and serialize those results back out. When the whole process finishes, we produce a patch from edits made during this process.
For you today. Thank you for your time. Please contact us to get a demo and to learn how to get started with the Moderne platform.